In this course, I will introduce to you what MPLC is capable of in terms of communication. I will walk you through some of the new features of communication for MPLC, including Function 151 Clink MD4 and MD5, Function 152 NCR, and MQTT. Please be noted that we will be using the following tools particularly in this course. MPLC Programming Tool, Upper Logic, at version 0.11.5. Modbus Simulation Tool, MQTT Broker Tool, Mosquito. You could obtain the latest version of Upper Logic by accessing the FATEC official website. MPLC and FB's PLC both provide Ethernet and serial communication. However, MPLC specifically distinguish their use by introducing different ladder instructions. For example, for Modbus communication, we use function 152 for Ethernet communication, yet we use function 150 for serial 1. When it comes to Ethernet communication, MPLC supports FATEC binary protocol, which will be open to the system integrators and alike. Modbus TCP master and slave are also supported by using function 152 for master and with proper configuration for slave inherently. Not only that, socket communication on UDP and TCP is coming soon, and the Ethernet version of CPU Link, M-Link, is also on the way but unfortunately still in design phase. Regarding serial communication, MPLC supports FATEC binary protocol and Modbus RTU and ASCII master and slave by using function 150 for master and with proper configuration for slave inherently. In terms of compatibility, MPLC is compatible with CPU Link function 151 MD3, which allows integration of high-speed communication with FB's PLC. Other than the original modes, MD4 and MD5 are added for different use scenarios. MPLC incorporates a great deal of different IoT services, with aims to achieve remote access, monitoring, and maintenance of the application. MQTT is a lightweight communication protocol dedicated to the use of IoT applications. High efficiency and reliability provides a seamless way of exchanging messages among various devices. FATEC Cloud iMonitor is a monitoring service which allows users to access PLC device memory remotely, to stay on top of the operational status of the machines of interest at any time and from anywhere. FATEC Cloud iAccess is a maintained service which allows users to operate on PLC remotely, including downloading and uploading project. These are essential features that help reduce the cost and improve the efficiency by a great deal with MPLC. MPLC adds two modes for function 151, MD4 and MD5. The difference of MD4 and MD5 from MD1 and MD2 lies in that MD4 and MD5 operates on continuous byte transfer. The following table demonstrates how MD1 and MD2 put the data 0x12345678 into the memory, which may require reassembling, which is often time-consuming, and use up more registers, whereas MD4 and MD5 put the same data byte-wise continuously, which saves the time of reassembling and the used registers. Function 151 is compatible with 1 and FBs, only adding new modes MD4 and MD5 for MPLC. Here's an example. A function 151 sends 0x12345678 on port 1 with MD4 and the other receives the data on port 2 with MD5. We loops back from port 1 to port 2 to examine the process, and we can thus observe how the data is transferred from R3R4 to R309 R310 byte-wise continuously. MPLC is equipped with RJ45 port, and function 152 serves as the instruction for Modbus TCP master. The use of function 152 is very much similar to function 151. The noticeable difference, however, lies in the fact that function 152 requires remote IP address instead of station number. The design of function 152 and function 151 is very much alike, both of which shares the same idea of inputs, outputs, and communication table. Here's an example. MPLC communicates with a Modbus TCP simulation tool run on a PC through function 152. We can observe from the communication table with D0 D9 on the PLC being transferred to 4x00014x00010 on the PC and 4x00014x00010 on the PC being transferred to D10 D19 on the PLC. After making change to the registers, we can observe the change in 4x00014x00010 with the simulation tool at once. Let's implement the example of function 152 in CR step by step. Run the simulation tool of Modbus TCP server on your PC. Configure the tool as using TCP connection. Configure the IP address of the PC as 192.168.2.8. For the default IP address of MPLC is 192.168.2.4. Connect the MPLC with the PC with the Ethernet cable directly. Use the combine tool on the PC to ping the PLC to make sure the connection is ready. Create a new project using UpperLogic. Program using function 152. Create a communication table for function 152 and add steps. Step 1. Write D0 D9 to 4x0000014x00010. Step 2. Read from 4x0000014x00010 to D10 D19. Download the project and run. Use online monitor mode to monitor the registers. Enable the function 152. Change D0 D9. Observe the change in 4000014000010 with the simulation tool on the PC. Save the project as practice 2. MQTT is a standards-based messaging protocol or set of rules used for machine-to-machine communication, even with limited bandwidth over a resource-constrained network. Smart sensors, wearables, and other Internet of Things, IoT devices alike can still transmit and receive data effectively. MQTT has the following advantages. 1. The protocol is open and thus no additional charge of use. 2. The lightweight design inherently well exploits the bandwidth. 3. Being one of the mainstream IoT protocols. 4. Supports QoS and therefore well adapts to the condition of a network. Next on the list, we will learn more about the integral parts of configuration, publish, and subscribe of MQTT. MPLC incorporates the MQTT protocol at version 3.1.1. Mosquito is an open-source MQTT PC tool that supports MQTT protocol at version 5.0, version 3.1.1, and version 3.1, which we will be using in the following practice. The configuration of MQTT can be found in the server configuration page in the project management window. In this practice, we configure the basic as the following settings in order to connect to the MQTT broker. Some of the essential settings are hostname/IP, port, client ID, as well as username and password if required. The configuration of publish is as the following settings, where we use JSON with QoS of level 2, and we publish D0, D9 to the MQTT broker. The configuration of subscribe is as the following settings, where we use JSON with QoS of level 2, and we subscribe to the topic name 0_topic 0, and put the relevant subscribe data to D20, D29. Before we proceed with the practice of MQTT, please first follow this installation guide to complete the installation of the designated MQTT broker tool. We will walk through some step-by-step instructions in order to complete the installation. Let's make sure we have all downloaded the proper installation file before we move on. Make sure once again that we have all downloaded the suitable installation file. Start the installation file. Deselect the checkbox Service so it won't be executed as a Windows service. Hit Next until the end of the installation. Now the installation is complete, let's move on to configure the tool. Locate the path and open the folder where the tool is installed. The path should normally be found at C:\program files \mosquito. Create a file, urls.txt, under the installation folder. Fill in username and password accordingly, and save the file. Find the configuration file mosquito.conf in the installation folder. Open it, and append the following selected text. Start the Windows command line tool as an administrator and execute the following commands sequentially. If successful, the tool should be up running. We are now finished with the installation. Let's implement this process of MQTT based on practice 2. Now that we have run the MQTT broker successfully, and we have configured the hostname/IP, port, client ID, as well as username and password required in this practice, configure the publish settings, where we use JSON with QoS of level 2, and we publish D0, D9 to the MQTT broker. Configure the subscribe settings, where we use JSON with QoS of level 2, and we subscribe to the topic name 0_topic 0, and put the relevant subscribe data to D20, D29. Make change to D0, D9. D20 D29 will change every 5 seconds of period accordingly. Please feel free to ask any question or make any suggestion to the local FATEC distributors worldwide, or leave a message on the website.